Hello students and friends. Today's video focuses on some concepts and problems related to gas laws. So stick around, watch and learn. Question number 1 is a conceptual question. Consider the three statements below. Statement 1. At constant volume, the absolute pressure of a gas is directly proportional to the absolute temperature. Statement number 2. The volume of a given amount of gas is directly proportional to the absolute temperature when the pressure is kept constant. Statement number 3. The volume of a gas is inversely proportional to the absolute pressure applied to it when the temperature is kept constant. Question is, which of the following correctly identifies the above statements? Alright, so option letter A, the first statement is Boyle's law, the second statement is Charles' law, the third statement is Gay-Lussac's law. For option letter B, the first statement is Gay-Lussac's law, the second statement is Charles' law, and the third statement is Boyle's law. For option letter C, the first statement is Charles' law, the second statement is Boyle's law, and the third statement is Gay-Lussac's law. And option letter D, the first statement is Boyle's law, the second statement is Gay-Lussac's law, and the third statement is Charles' law. The best answer is option letter B. Statement 1 is Gay-Lussac's law, statement number 2 is Charles' law, and statement number 3 is Boyle's law. Question number 2. A container is filled with a mixture of helium and oxygen gases. The thermometer in the container indicates that the temperature is 22 degrees Celsius. Which gas molecules have the greater average speed? Alright, letter A, option letter A, helium molecules because they are monatomic. Option letter B, the same, both because the temperatures are the same. Option letter C, oxygen molecules because they are more massive. And option letter D, helium molecules because they are less massive. The concepts applied in this question is that temperature is the average molecular kinetic energy of the molecules. Alright? So formula for kinetic energy is 1/2 the mass times the square of the speed. So since the temperature of the mixture is given, we can say that the kinetic energy of all the oxygen molecules and the helium molecules on the average is the same. But some of these molecules are moving faster than the other molecules. Now, which gas molecules have the greater average speed? Alright? So at constant kinetic energy, we say that the molecules with the lighter mass, with a smaller mass, are the ones moving with greater average speed. And since we know that helium has a lighter atomic mass than oxygen, alright? As a molecule, oxygen is diatomic. That means its atomic mass as a molecule is 32 atomic mass unit, whereas for a helium molecule, it's only 4 atomic mass unit. And therefore, our answer among the four options is letter D. Helium molecules, okay, have the greater average speed because they are less massive. Question number 3. An ideal gas occupies 300 liters at an absolute pressure of 400 kilopascal. Find the absolute pressure if the volume changes to 850 liters and the temperature remains constant. Alright, notice that each of these given quantities have three significant figures. So we have the following options. Letter A, 141 kilopascal. Letter B, 640 kilopascal. Letter C, 850 kilopascal. And letter D, 1140 kilopascal. The solution to this question, all right, we first identify the given data. For our initial volume, it's equal to 300 liters. That's V1. And the final volume, V2, is equal to 850 liters. Both of them have three significant figures. We're also given the absolute pressure, P1, equal to 400 kilopascal with three significant figures. And we're asked to find the final absolute pressure, P2. The formula that we're going to use in determining the final absolute pressure is given here, right? P2 is equal to the product of V1 multiplied by P1 divided by V2. All right? So you should recognize that this is the formula for Boyle's law. Understood that in here, the temperature, Kelvin temperature, is held constant. All right? So substituting our given data, we have 300 liters, that is V1, multiplied by 400 kilopascal, that's P1, and divided by 850 liters, that is V2. Okay, doing our math, we will get the value for the final absolute pressure equal to 141 kilopascal. All right, therefore, our answer among the four choices is, of course, letter A, 141 kilopascal. Question number 4. 2 liters of a perfect gas are at 0 degrees Celsius and 1.0 atmosphere. The gas is nitrogen, N2. Determine the number of molecules. Choices are letter A, 3.5 times 10 to the 22 power molecules. Letter B, 5.3 times 10 to the 22 molecules. Letter C, 4.7 times 10 to the 22 molecules. And letter D, 7.4 times 10 to the 22 molecules. So for our solution, our goal is to determine the number of molecules of nitrogen, right? So we first identify the initial temperature is equal to 0.0 degrees Celsius, and that is 273 Kelvin. We are also given the initial volume, V1, that is 2.0 liters, which when converted to the SI unit, meter cube, that's 2.0 raised to the negative 3 meter cube. Also, we are given the initial pressure P1, which is equal to 1 atmosphere, and 1 atmosphere is equivalent to 1.0 times 10 to the fifth Pascal. So, this formula, PV is equal to capital NkT, is one version of the ideal gas law equation. Alright? In this formula, the constant K, which is known as the gas Avogadro's or gas Boltzmann constant, which is the ratio of the universal gas constant capital R to the number of molecules corresponding to Avogadro's number. Alright? So when you divide the universal gas constant, which is 8.31 joules per mole Kelvin, by Avogadro's number, 6.02 times 10 to the 23rd power molecules per mole, we will get the value of this constant K equal to 1.38 times 10 to the negative 23 joules per Kelvin. Alright? So, since we are looking for the number of molecules, capital N, we isolate capital N in this formula and come up with the working formula. Capital N is equal to pressure times the volume divided by the product of K and the absolute temperature T. Substituting the given, we have 1.0 times 10 to the fifth Pascal, that's the pressure, multiplied by, alright, the volume, which is 2.0 times 10 to the negative 3 meter cube, and then divide that by the product of the value of K, which is 1.38 times 10 to the negative 23 joules per Kelvin, and the absolute temperature, 273 Kelvin. So simplifying, what we get is, for the capital N, or the number of molecules of nitrogen, equal to 5.3 times 10 to the 22 molecules. That means our answer to this question is option letter B, 5.3 times 10 to the 22 molecules. This is the last question, question number 5. A balloon has a volume of 1.0 meter cube. As it rises in the Earth's atmosphere, its volume expands. What will be its new volume if its original temperature and pressure are 20 degrees Celsius and 1.0 atmosphere, and its final temperature and pressure are negative 40 degrees Celsius and 0.10 atmosphere? The choices are letter A, 2.0 meter cube, letter B, 4.0 meter cube, letter C, 6.0 meter cube, and letter D, 8.0 meter cube. The solution to this problem is applying the formula of the combined gas laws, right? And since we're looking for the final volume, okay, V2, we simply multiply the initial pressure by the initial volume and the final temperature, which must be in Kelvin. Then divide the whole thing by the product of the initial temperature, also must be in Kelvin, and the pressure, final pressure P2. So substituting, all right, the given initial pressure um, is 1.0 atmosphere, but in Pascal, that is equivalent to 1.0 raised to the fifth power Pascal. All right, Pascal, we know, is the SI unit for pressure. So we multiply that by the volume V1, which is 1.0 meter cube, and multiply that also by the final temperature, which is actually negative 40 degrees Celsius, but when converted to Kelvin, its equivalent is 233 Kelvin. All right? Then divide this by the product of the initial temperature, which is 20 degrees Celsius, or its equivalent in Kelvin, 293 Kelvin, to be multiplied by the final pressure of 0.10 atmosphere, which when converted to Pascal, it is 1.0 raised to the fourth power Pascal. So doing our math, okay, the final volume of the balloon V sub 2 is equal to 8.0 meter cube. In other words, our answer to this question, of course, is option letter D, 8.0 meter cube. So that's it. We are done with our video tutorial. Thank you very much for your indulgence. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.